Welcome to clickmyproject.com. Now let me discuss about blind separation of superimposed images with unknown motions. Here we provide a novel method for the separation of two images. Initially we fused the two images. From the fused image we are finding the gradient of fused image. The gradient is the finding edge of the image. The gradient value will be 0 and the edges of the image value will be differ from the 0. After that we are finding the matched layers from the gradient image. From this layer we are separating the original source layer. We develop a sparse blind separation algorithm to estimate both parameterized motions and mixing coefficients. Then a novel reconstruction approach is presented to recover layers by utilizing not only the mixing model but also the statistical properties of natural images. The whole method can handle more general motions than translation, including scaling, rotation and other transformations. The separation method contains two main parts. One of which is to estimate the mixing model and the other is to reconstruct the layers according to mixing model. This is the flow of our project. Here we have to provide two images input. The two images pass to the image fusion. For separating the images it should be mixed with one or more images. The mixed image is denoted as a layer. In this model only the mixtures of image 1 are known and the unknown images are the layers. The goal of the method is to correctly estimate the layer number and the mixing parameters and to recover the unknown layers. For the fusion image, here we use the wfuse image function in MATLAB. The fused image will pass to the image gradient. In this module we convert the image as gradient. The gradient is the edge of the fused images. The sparsity denotes that almost all gradients are equal to 0 and only the small part of the or significantly differ from 0. The gradients significantly differ from 0 are called the significant gradient. The gradient is passed to the mixing coefficient. The first step in estimating the mixing coefficient is to calculate the scatter plot. For this we apply the motion candidate found after by optimizing the motion objective function to estimate the coefficient. We remove all the points near the origin by setting them to 0. After finding the mixing coefficient it will go to the matched layers. Here we extract the matched layers in the image gradient of the fused image. We produce n scatter plots. We also can eliminate the gradient matched by the other candidates to make feature lines more clear. The line clustering algorithm can be used to detect the scope of the feature lines matched by each motion candidate. After finding the matched layer, it will go to the image separation. Here we separate the coefficient values of the fused image. The reconstruction step is the final crucial part of the separation. These gradients show clear shapes of layers and can greatly help the reconstruction. So we want to find the layers that agree with not only the mixing model but also exacted gradients. Finally we get the separated image as the output. Now let's read the execution part. Here I am having blind main.fl. This is the main file. Select this file, right click, run the file. The GUI window will be open. This is our GUI design of our project. Here we have to provide two images as an input. Now I am providing one image here. The provided first image is displayed in the first axis. Here we have to select another image as input. The selected image is displayed in the second axis. Here we are going to fuse the two images. the fused image will displayed on the third axis. This is the fusion result. It will be fused by the wfuse image function in MATLAB. After that, here we are finding the gradient of image. Gradient is nothing but it is the edge of the image. Now let's see the result of this. This is the gradient of the image. After that, here we are going to find the image separation. For separating the image, here we are using the algorithm of sparse blind separation algorithm to estimate both parameterized motion and mixing coefficient. Then a novel reconstruction approach is presented to recover layer by utilizing not only the mixing model but also the statistical properties of the natural images. Now let's see the result of image separation. Here the sparse coefficient will be displayed here. The separation of the coefficient values will be plotted in a chart plotted here. After separating the coefficient, finally we will get the separated image. Here iteration is going on. This is the final result of the separation of provided image. This is the our provided source image 2. This is our provided source image 1. From the fusion image, here we are separating these two images. Our method will provide the better result than the other. Thank you.